Hello, algebra students. Mr. Lawrence here, and this is one of the review videos I put together for you. I'm doing this on Friday night because I care about you guys and I want you to do well. You've got to do the work, but I'm willing to work with you, okay? So let's first of all review really quick rational and irrational, all right? The irrationals, they're decimals. They have to be a decimal, right? It's a decimal. It's a decimal. But these decimals have two characteristics, that they have to have. One, they can never terminate. They never terminate. Irrational numbers never terminate, which does mean they go forever. But that's not enough to make one irrational. A number to be irrational also has to never, 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 never repeat. Never repeat. Okay? Never terminate and never repeat. All right. To be rational, it could be a decimal, right? They could be a decimal. But if they're a decimal, they must do one of two things. They're decimals that either terminate or repeat. They do one of those two things. If they don't do either of those two things, irrational. If they do one of those two things, they're automatically rational. Now, by the way, it's also important to note that all rational numbers include all fractions, because all fractions can be converted into a decimal that either terminates or repeats. All right, so what I want you to do is I want you to pause the video and I want you to sort these numbers here. Each number is a different color, all right? Pause the video, sort them, and when you're ready, unpause and you'll see my solutions. All right, now I'm getting ready to give you my solutions, but I'm going to tell you why each one is either rational or irrational. And hopefully when you sorted them, you were thinking or saying or writing these things too. If you haven't done it, go back and do it right now. Like 6 and 23 hundredths, but the 3 is repeating there. You know, that's going to be rational. Why? Because it's a repeating decimal. So my reason would be it's a repeating decimal. Okay, so go ahead and pause the video. If you don't have reasons for the rest of these numbers, put them in there. Okay, here we go. 3/4. That's going to be rational. How do I know? Because all fractions are rational. Yeah, if I convert that to a decimal, it'll either terminate or repeat. It'll actually terminate. Okay, I know 4 2/10 is rational. How do I know? It terminates. How about 22/7? Well, all fractions are rational. Okay, 22/7 is not pi. It's a close approximation of pi, but it can't be pi because it's a repeating decimal. It's 3.142857. No, yeah, 57, 142856. No, 142856. No, it is 7. 142857. And it's going to go 0.142857, 142857 on forever in those 6 digits repeating. All right, how about 3 14 hundredths? Yep, you guessed it, rational. Why? It terminates. How about the square root of 7? Well, that's irrational, right? -5. It terminates. Put it in the rational side. 0. It terminates. 12. It terminates. Now you might be thinking that, wow, there aren't very many irrational numbers. And that's not actually true. There just aren't that many examples up here. Another example could be like 6.412 with the dots after. That is a decimal that goes on forever. It doesn't terminate and it doesn't repeat. There's no pattern to it. Okay, that's another way to express an irrational number. And there's actually lots and lots of irrational numbers. Okay, next part. I've got 5 different numbers here, and I want you to tell me which subsets of the number systems they belong to. So I'd really love for you to pause this video, see if you can determine which subsets each of these different numbers belongs to. You can use the names or the numbers. You know, N is natural, W is whole, Z is integer, Q is rational, I is irrational, and R is real. All right? When you're ready, see my solutions. All right. 0 is a whole number. It's not a natural number. It's a whole number. and it's also an integer. It's rational, and it's real. So 0 belongs to all 4 of those subsets. -2/5. Well, all fractions are rational. Integers don't include fractions. That's a rational number, and it's also a real number. Okay, -7. It's not natural, it's not whole, it's an integer. The integers include the whole numbers and the negatives of the wholes. It's also rational because it's a decimal that that terminates. You could say it's a decimal that's repeating. -7.0 repeating, right? Okay, and it's, of course, a real number. All right, square root of 15. What is the square root of 15? I'll bet you don't know, and that's a good thing because there is no square root of 15. Square root of 15 is an irrational number. It's a decimal that goes on forever without repeating. There is no number times itself that equals 15. All right, it's also real. And then finally, 6 31/100ths with the 1 repeating. All right, well, that's a repeating decimal. So that makes it rational. And, of course, it's real. Okay? Now, if you'd like to send me a question or something about these or ask about them on Monday, that's fine. But this is just a quick video for a little bit of review and a little bit of practice for you. All right, Mr. Warren signing off, getting ready to go make my other video.